Okay, this is your study guide for the second half of Chapter 5 worked out for you, and I will be giving you tips about the test as I work through it. So hopefully you'll listen to all of it and take notes and remember what you need to move forward. Okay, so first off, this study guide has, I believe, 17 questions. You will have the same number of questions. The only thing that's going to be different is I'm changing the numbers. So make sure you understand what's being asked of each problem and let me know if you have any questions. And feel free to pause at any time to come ask me questions. So first off, it says, is 7,6 a solution of the system below? Justify your answer. So if it is a solution, then it will be true when we plug in the values into each equation. So I have to do it for both of them. So this, of course, is my x. This is my y. So that means that I'm going to plug in 3 times my x, which is 7, minus 9 times my y, which is 6. And I'm going to see if that equals negative 33. Then I'm going to do 4 times my y value, which is 6. Does that equal 8 times my x value of 7 minus 31? So when you plug those in, you will find out that the first one is true, so that one works out, but the second one is false. And they have to both work for you to say that it is a solution. As I said, this is negative 33 equals negative 33. This is 24, and 24 doesn't equal 56 minus 31. So the answer to this is that a solution, no. And when I ask you to justify it, this is what you need to put down to show me your justification. If they are both check, then the answer is yes. If either of them is no, the answer is no. If both of them is no, the answer is no. Okay, number 2, solve the system by graphing. Okay, there are two things we've talked about. When both x and y are on the same side, look and see, does 4 go into 10? And it doesn't. So this one might be easier to rewrite by taking the 4x to the other side. I take it to the other side by subtracting, which means that this is y equals negative 4x minus 10. And that one you're going to graph as if you're doing y equals mx plus b. So you start off with your b, that's my b, 0, negative 10, and your slope is rise over run, in this case negative 4 over 1. So when I start with that, negative 0, negative 10 is my y-intercept, and then I go up 4. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. I don't know where they're going to cross. 1, 2, 3, 4 over 1. So I'm going to fill up this whole graph. 1, 2, 3, 4 over 1. Because I'm looking for that point of intersection. 1, 2, 3, 4 over 1. Okay? So when I plot that, let's go ahead and graph that. I'll go ahead and use this one. No, let's go with this one. And put an arrow on both sides and make it match so that we can easily tell which line goes with what. And when I connect, it's going to look like this. Okay, so now let's go graph this one. And this particular line, 4 goes into 8 and 4 goes into 8. So I'm going to use my intercepts, which so I'm going to go find out what happens if x is 0 and what happens if y is 0. And if x is 0, I have 4y equals 8 and divide both sides by 4, and I find out that y equals 2. So I have the point 0, 2 on my graph. If y is equal to 0 and I cover that up, then I have 4x equals 8, and just like before, I'm going to find out that x equals 2, and that is plotted right here. So we've talked about how you can start from one point and count to the other to continue and figure out where that's going to intersect. So over 2, up 2, over 2, up 2, over 2, up 2. So that's where they intersect. I am supposed to solve by graphing. I'm going to go ahead and circle that point because I know that that's where my line needs to intersect. So we have this, and again, so that we can know which line goes where, I'm going to draw it to match. And kind of missed there. So let's fix that one. So now it goes through my points that I have. But again, this is the answer and this is what goes in the blank. Again, I'm solving it. So my solution is an ordered pair. So if I go put that in the blank, that is the point -4, 6. Now, I didn't require this in your study guide, but if you have time and on Thursday, long day, when you actually take the test, you will have time. So it would be in your best interest to check. And you check by plugging it back in. 4x plus something equals -10. And then 4x plus 4y equals 8. And what we're plugging in are the points. That's x is -4 and y is 6. So this gives us -16 plus 6, and that's -10. -16 plus 24 equals 8. So then you know that what you got is the right answer. Okay, moving along. Solve by the substitution method. Substitution method, I encouraged you to find the variable that was all by itself, which is y, and then I encourage you to circle what y was equal to, and then plug it into the other equation where you're going to substitute. So then when you write it, x plus 2 times whatever you're substituting is going to equal 45. So what am I going to plug in there? I'm going to plug in 5x plus 6 because that's what y was equal to. And then I'm going to simplify that. And that gives me x plus, you got to distribute, 10x plus 12 equals 45. And I'm going to subtract 12 from both sides and find out that x plus 10x, of course, is 11x. 45 minus 12 is 33. Divide both sides by 11, and you'll find out that x equals 3. So if x equals 3, remember, each time we do this, we're looking for an ordered pair to our solution. So if x equals 3, I'm going to take it and I'm going to plug it in right there for x to find out what y is. So y equals 5 times 3 plus 6, and y equals 21. So my ordered pair is 3, 21. And again, you can check it. Now I already put it into this one, so to check it, you really only have to put it in that first one. 3 plus 2 times 21, does that equal 45? 2 times 21 is 42, and 42 plus 3 is 45. So it checks. All right, the next two that we have are solved by what we call the addition method. Some people might remember it called the elimination method. And you're trying to, that was to remind you that one of the variables is eliminated when you add the equations. So if I straight out add these, x plus x is 2x, y minus y is 0, so I don't have to write that down, and 3 minus 5 is -2. So then we divide both sides by -2, by just 2, and you find out that x equals -1. Okay, you can go back and plug it in wherever you want. Okay, I'm going to plug it into the first one. So I plugged in -1 for x plus y equals 3. And to move that over, I'm going to have to add 1 to both sides. Okay, and some people mess up these easy problems because they don't want to write that plus sign to make sure these things are opposites. So that's what makes that go away and give me y equals 4. Again, always looking for that ordered pair, and x goes first, so we would write -1, 4. And you can check that. -1 plus 4 is 3, and negative 1 minus 4 is, of course, negative 5. So that one checks out. Okay, this one, if you notice, I got 6x and 7x, and then I have 31y and 35y, neither of which have the same coefficient. That's the number in front of your variable. So I'm going to have to multiply both of them by something. But the other thing you got to keep in mind is this guy needs to have y brought over. So when I bring y over, if I take it to the other side, that would be by subtracting from both sides. So I get this equation. So I'm going to have to multiply this one by 7. So we're going to multiply this one by 7 and this one by 6. And let's see what we get. So when I multiply that by 7, 7 times 6 is 42x. 7 times 31 is 217y. 7 times 4 is 28. 7 times 6 is negative 42x. 35 times 6 is 210. And 7 times 6 is 42. So when I add these two, you'll see that my x's fall out. Negative 217 plus 210 is negative 7y, and 28 plus 42 is 70. So I'm going to divide both sides by negative 7, and I'm going to get that y equals negative 10. Again, you can put that wherever you want. I'm going to plug it into this first one because that has x by itself, or on somewhat by itself. So that means 6x equals 31. You always want to use the original equation um, when possible, plus 4. So 6x equals negative 310 plus 4. And that, of course, is negative 306. Divide both sides by 6. And I'll find out that x is equal to negative 51. So my ordered pair that I'm going to write, x is negative 51 and y is negative 10. Okay, and again, you can go back and check. We've already put it in this one, so to check on that second one, we would do negative 7 times negative 51 plus 35 times negative 10, and does that equal 7? So put this side in your calculator and you will find out that 7 equals 7, so it checks, and then you know that you'll have the right answer. Okay, next page. Sorry it gets cut off. It says solve by whatever method you want. If necessary, identify whether the system has no solution or infinitely many solutions, and then use set notation to express the solution set. So I'm going to do each of these. The first one, 3x plus y equals 11 and y equals 12 minus 3x. Um, my y is by itself, and so I'm going to go ahead and I'm going to circle this, and I'm going to plug it in for that y right there, which means that I'm going to have 3x plus whatever I'm plugging in is equal to 11, so it just makes it easier to identify. Now, I don't really need those parentheses because there is a plus sign in front. So if I just add these, I find out that 3x minus 3x goes away, leaving me with 12 equals 11. And of course, we all know that that is false. That's not what you put in the answer blank. You put in the answer blank no solution, or you can use that symbol. Okay, the next one that we have, 4x plus y equals 17, 21 minus 9. Okay, there's no x there, so simplify this and go ahead and solve this one. 21 minus 9 is 12, equals 3y. Divide both sides by 3, and I find out that y equals 4. So I'm going to go plug that in. If it said 3y, I'd plug in that, but it says y. So I'm going to plug that in and find out that I have 4x plus 4 equals 17. Subtract 4 from both sides. 4x equals 13. Divide both sides by 4. And x equals, I'm going to go up here so I don't run into the next problem. X equals 13 over 4. So my ordered pair is 13 over 4 because that's my x, and my y is 4. There is no x value to plug in and check, so the fact that we did that, you can plug it back in and check it, but you're basically done with that, and that's the answer. Okay, so the next one, we have 2x plus y equals 7, 8x plus 4y equals 28. So you can take the 2x over and plug it in. I tend to find more people make mistakes that way, so I'm going to go and take the first problem and I'm going to multiply it by negative 4 because 2 times negative 4 will give me a negative 8. So that's a negative 8x, and then I'm going to have minus 4y equals negative 28. So when I simplify that, actually I'm going to find out that that's 0 and that's 0. Have to write that 0, and 28 minus 28 is 0. So 0 does equal 0, wherever you figure that out. It's true. So this time we have our ordered pairs, which infinitely many solutions. Any ordered pair x and y that satisfy one of those equations. It does not matter which one you write. And unfortunately, you can't check it when it's infinitely many solutions. You can take an ordered pair, but it has to satisfy one of those equations before you plug it in. Okay, so let's go on to our graphing. And in our graphing, okay, 3x plus 4y, we've talked about this before. X and y are on the same side, and they both go into 12. So I'm going to do one where I plug in for x and the other one where I plug in for y. So if x goes away, I have 4y equals 12. Divide both sides by 4, and I'll find out that y equals 3. 0, 3. Y equals 3 intersects the y-axis. If I cover up my y and make it equal to 0, then I have 3x equals 12. Divide both sides by 3, and I find out that x equals 4. So it intersects the x-axis at 4. Okay, this time it's an inequality. So I have to decide whether that is solid or dotted. And because it has the equal sign, I know that it's solid. So I'm going to go draw that line real quick. And let's take that one, but we'll change it to a solid line and connect these. And I did miss on that second point, so I'm going to fix it. So I'm connecting my intercepts, and now I have to decide also where to shade. And we've always talked about a test point, and we always test 0, 0 unless it includes our line. So if I put 0 plus 0, is that less than or equal to 12? That is true, so that means I'm going to shade the point that has 0, 0 in it, which is going to be this point. So I'm going to go highlight that, and then we'll go to the next one. Now, you can always check whether you've shaded by picking any point in this shaded region and plugging it into your line to see if it's true. Okay, so moving on to the next one. It says y is less than 3x minus 5. This one does not have x and y on the same side. So I'm going to treat this one like y equals mx plus b and find out that my y-intercept is 0, negative 5, 0, negative 5, and then my slope is 3, which is 3 over 1, which means I'm going to go up 3 and over 1, and up 3 over 1, up 3 over 1. And y'all probably don't want to do any more than that. But we are supposed to fill up our graph, so I'm actually going to keep going. Or I could go down 3 and to the left 1, down 3 and to the left 1. Okay, so the other thing we have to do is we have to look at this and decide whether or not our line is solid or dotted. It is dotted because this is just a less than. It is not um, equal to. So when I connect these, I'm going to make it dotted. And because y is by itself, then the fact that y is less than means I'm going to go below my y-intercept. So here is my y-intercept. Below would be this way. So that means that I'm going to shade below this line, which is all of this area. And like I said, I'm not doing that well with coloring in the lines, but y'all have the understand. And you do need to shade all of it up to the line so that I know that you know exactly what that shaded region is. Okay, next page. Two more. X is less than or equal to -2. Remember, if it says X, it's going to intersect the X-axis, and it's going to intersect the X-axis at -2. Okay? Again, equal to means our line is going to be solid. So I'm going to go graph a solid line that will intersect the x-axis at -2. So that gives me that line right there. X is less than. This is a less than. And how do I go? When I'm looking at that number line and here's -2, less than is in this direction. So that means that I'm going to shade in that direction. So Um, again, you can take a test point in this shaded region anywhere and test it if you need to. All right. Next, we have a system, which means we're going to do two on the same side. This first one, when I'm looking at it, x plus 2y, they're both on the same side and they both go into it. So I'm going to go find these points. I'm going to plug in 0 for x. I'm going to plug in 0 for y. So if I plug in 0 for x, it goes away. 2y equals 2. Divide both sides by 2, and y equals 1. So I have the point 0, 1. Then if I plug in a 0 for y, then I'm going to find out that x equals 2. So x is equal to 2 here. And again, if I go down 1 over 2, down 1 over 2, then I can find, you do want to, especially when you're doing your graphing, so it's a good habit just to be able to continue this pattern. If I go up 1, I would go to the left 2, up 1 to the left 2. And next you want to look at it and determine if it's going to be solid or dotted. This one equal to, so it's going to be solid. So let me go get my line and draw, connect my dots. So when I connect my dots here, okay, now again, x and y are on the same side, so this time I'm going to choose my test points of 0, 0, and 0 plus 0, is that less than or equal to 2? And that is true. So that means this line I'm going to shade that way because that would include my 0, 0. Now, if we go do the next one, this one is a little tricky because you put 0, 0 and you get 0, and that's only 1 point. So this one, it might be better to subtract the x, and that would be y is greater than -x. Okay, you still have a y-intercept of 0, 0, as we just figured out, but my slope in this case is -1, which is -1 over 1. Write that a little bit better. So if I go up one, I'm going to go over one, up one, over one. That's where they intersect, and down one, over one. So is my line solid or dotted? When you look at that, no equal sign, so it's going to be dotted. And so let's go get a dotted line. Actually, I got to get the line. And I need it to be pink so it can match my points. And it's going to look like this through here. Actually, that goes to 11, doesn't it? That should work still. That connects. Okay, and it says y is greater than negative x. So y is greater than negative x means I'm going to go above it. Okay, so draw it on both sides of this point of intersection, and then you'll see I don't shade that because I don't have arrows pointing it to it. This one does not have both arrows pointing, but this one does. So that tells me that my point of intersection that I want to shade is going to be this area right here. And y'all could probably do a better job of that than I can do with this mouse. But this is my region of intersection. Okay? And we have two more of those. We have a line that says y is greater than 3. Again, we've talked about y is going to intersect the y-axis at 3. So, and my line is going to be dotted. Okay, and actually I should say intersects because I don't want you to think it's parallel, but it intersects the y-axis. It is going to be dotted, as I just said. It's going to be green, so I'm going to go through right here. Okay, and if you look at the equation, it says y is greater than. So hopefully you know greater than means I'm going to go above it. So I'm pointing my arrows that way. When I go to x is greater than or equal to negative 5, this one is going to intersect your x-axis. I didn't write x. At negative 5, and my line is going to be solid. So we'll go get my line. I need a solid line this time, and it will be through at negative 5. So this is negative 5. Okay, and x is greater than, so greater than is this way. So again, if you find that region that is common to both, has the arrows pointing, you'll find out that that is this region right here. So that's the solution. And we have many solutions that satisfy this system of inequalities, which is why we have a shaded region. Okay, number 14. Again, we have talked about this. The 5 and 10, x and y are on the same side. They both go into 10. So 0, something, and then something, 0. If I cover up 5x, then 10y equals 10. So divide both sides by 10, and I find out that y equals 1. So I'm going to plot the point 0, 1. Then if I plug in 0 for y, then I'm going to have 5x equals 10. Divide both sides by 5, and x equals 2. Sounds like a familiar line. We'll have to change that up. So, over 1, up 1, over 2, up 1. Over 2, up 1 is what's continuing this line. Down 1, over 2. Down 1, over 2, when I count from one to the other. Is it solid or dotted? It is solid. And my test point, 0 plus 0 is less than or equal to 10. And that is a true statement. Now, if you don't write this on there, or if you don't write above and below somewhere on there, I don't really know that you know how to know where to shade. So the more that you can put on there, the better it's going to be for me. So I need a solid line uh, going through these points. So let's go. All right. And 0, 0 was true, and so that means that I'm going to shade this way on my line because that's where 0, 0 is on that side of the line. Okay, 2x plus y is less than or equal to 6. Again, 2 and 1 both go into 6. So I'm going to put in 0 for x and then 0 for y. So 0 for x says y equals 6. So I'm going to plot the point 0, 6. And 0 for y tells me that 2x equals 6 divided by 2 and x equals 3. So I have 3, 0. Okay. And just to speed up, because hopefully y'all know by now. Oh, I didn't talk about whether it was solid or dotted. It's equal to, so I know it's going to be solid. And my test point, well, we'll go ahead and draw that first. So if I draw that, making sure I have an arrow and match. Then we're going to go through, I need to adjust that to contain my points. And when you all adjust it, that might mean erasing, so you do need to make sure you do that. If I put in 0, 0, that says 0 plus 0, is that less than 6? Less than or equal to 6. Again, that one is true, so that means I'm going to shade this way. And now you can see that our point of intersection is points in common, is this region right here. So this carries forward to the last couple of problems that we have, which is linear programming. And this time we have to be really careful about our points of intersection because those points are what's important. However, on the first ones, I give those to you. So in this first one, find the values that maximize or minimize the objective function for each graph. So you're going to go and take each of these points, A, B, C, D, and plug them in to your profit equation. So if I plug in, if you want to start, and notice that I do number them, so A is going to say P is equal to 4 times 0 plus, I'm sorry, I don't know where I got 4, I think I was reading something. Alright, so I have 5 times 0 plus 3 times 0, and that equals 0. B, profit's going to be 5 times 6 plus 3 times 0, that equals 30. C, profit's going to be 5 times 2 plus 3 times 4. 10 plus 12 is 22. And then we have D, which the profit's going to tell us 5 times 0 plus 3 times 4, which is 12. So I'm looking for a maximum, so you've got to give me the maximum value, and that is 30. Okay. For C, this time I actually only have two. I have A is, oh no, A is right there, so I have A, B, and C. So A, my equation is C equals 4 times X plus 3 times Y. 8 plus 3 is 11. Then I have B, and B, my cost says 4 times 3 plus 3 times 0. 12 plus 0 is 12. And then C tells me my cost is 4 times 0 plus 3 times 5. And that tells me that it is 15. Now be careful, okay? It's asking for what this time? It's asking for a minimum, so this time you give me the smallest number. Okay? All right, and the last problem, we have to graph them, find that feasible region, and then determine the solution set. So in graphing this first equation, y equals negative x plus 4. I have a y-intercept of 0, 4, and a slope of negative 1, which is, of course, negative 1 over 1. So I'm going to start at 0, 4, and down 1 over 1, down 1 over 1, down 1 over 1. I'm going to go all the way. On these problems, you really always want to go at least to the other axis. My line is solid, so I'm going to get a solid line. I'm going to speed it up and not put arrows because that's, and we'll go like this. And it looks like I missed a little bit at the top. Alright, so there's my equation. It is solid. And we'll go to the next one. The next one says y equals negative 1/3 x. So I have 0, 2, plus 2, and my slope is negative 1/3. Again, it's going to be solid. So I'm starting at 2, down 1 over 3. Makes that point in common. Down 1 over 3. And as I said, you really want to do both of them because as you see, it's often in that. So we'll go here. That looks pretty good. And actually, one thing I didn't do. Y is less than. So I'm going to find that y-intercept means I'm going to go less than here. And on this one, again, y is less than. So I'm plotting this point. Okay. X is greater than 0. Okay. X is greater than 0 and y is greater than 0. So hopefully you remember enough from what we've done. Let's go plot these with that. So we have this line and we have this line, which I kind of missed. And that means that, and both of those are x greater than, x greater, or y greater than. And so when I graph those, hopefully you realize from the many that we've done that this right here is the region that we're looking for. So you get that region, and as I tell you in the directions, the next thing you want to do is find your vertices. So if I find the vertices for this, you know, it might help you. A, B, C, and D. So A, of course, is 0, 0. B is 0, 2. C is 3, 1. And D is 4, 0. So if we go plug those in, this is my function, 2x plus 3y. It's a cost function. So 2 times 0 plus 3 times 0 is 0. Point B, my cost, is 2 times 0 plus 3 times 2, which is 6. Point C is 2 times 3 plus 3 times 1. 6 plus 3 is 9. And D, our cost is 2 times 4 plus 3 times 0, and that's 8. So my maximum cost is going to be at the point 3, 1, which gives me an answer of 9. So there's your study guide. Make sure you understand each of these problems, and if you have any questions, please come see me.